Hey guys, this is 5.3 and 5.2 sine and cosine function and their transformations. This is not a lesson, it's actually just a summary because these two lessons are basically investigation on your own. You can simply figure that out. But time to time, 5.3 can lead you into a little trouble, so I am making this video, okay? Now, before we start the 5.3, we have to go over some of the terminologies here. Time to time, sine and cosine functions can be called a sinusoidal functions, as you can see right here. I'm just going to highlight it. Okay, sinusoidal function or sinusoidal graph, that means it is a sine or cosine functions. Now, then, the things that we can see in the real life as an example of these is, for example, a earthquake waves or a radio frequency waves, like something that goes up and down and up and down with the periods or repetitive cycles. Then it's basically can be considered to be a sinusoidal. Now, so before the transformation, we need to know the characteristics of the sine and the cosine functions. So it basically is these four things. Okay, it's basically these four things, and they share the same characteristics. The only difference between those two is where the max happens or the min happens. In other words, where the graph or the cycle of that periodic function starts. So let's then take a look at the amplitude, and the amplitude is always 1. Period is always 1. No, sorry. Period is always 360. Okay, I don't know why it says 1. And the equation of the axis is always 0, not 1. So I'm going to change that. Now, sine graph starts from the equation of the axis, which is a 0. So this time was actually properly done. Whereas the cosine graph starts from the max. Now, for these two, obviously, angle starts at 0 or theta or the x, whatever the variable that you label for the degrees. The key points you must remember of is its max and where that happens, same as the minimum, and where the graph intersects with the equation of the axes. So these consists of 5 points in total. Okay, 5 points in total. So let's go over that one with the graph of the sine graph. Now I'm not going to draw the axes anymore. I'll say grade 11, we're smart enough to know where the axis is, or we're smart enough to imagine where the axis is. So the sine graph looks like this, and the equation of the axes goes in the middle like this. So the points that I want you to remember of are these 5 points as I am plotting. So the first thing is the starting point. It starts from 0, 0, and the max starts at 90 degrees, 0, and it comes back down to 180, 0. Sorry, the max is at 1, not 0. And the minimum is at 270, -1, and then the ending point is 360, 0. So hopefully you can see it. It only goes up by 1 and goes down by 1 from the middle line, which is the equation of the axes, as well as every interval per se is 90 degrees. And hopefully you actually can see it because it's just 1/4 of the whole period, right? It's the 1/4 of the whole period. So that actually is a useful information for later usage. Now, then let's take a look at the cosine graph. Cosine graph looks like some sort of a bell. It's kind of not really a best graph, I'll say. I'll just try one more time. I think it's still not the best, but it's somehow looking like this. The equation of the axes goes through the middle again. It's in between the max and the min always. And the max starts at this point, or the starting of the cosine graph, comes down to the equation of the axes, goes down to the minimum, comes back up to the equation of the axes, and then ends at the maximum again. So this is 0, 1. Same thing, 90, 0, 180, -1, 270, 0, and then ending at 360, 1. So hopefully you can see this, that their y values, well, are located in different x values, but their x values actually are the same. Okay, so when there is no transformation, the points or the intervals actually go up by 90 degrees, which is 1/4 of the actual function, or not the function, but the period. Okay, so then let's get into the transformation part. Now, when you're looking at the transformation part, it basically is the same as the transformation that we dealt with before, something looking like y a f at k, x minus c and then plus d, right? Hopefully you remember these. So remember the A actually represents the vertical stretch or compression, and then it does also represent the vertical flip or reflection on the x-axis. For the K, then is the horizontal stretch or horizontal compression, and the reflection along the y-axis. So it's rotating this way, right? And then C is the movement of the sideways. So in this case, we call it horizontal shift, or we can say phase shift as well. Time to time, you will hear that term, so do not get confused. Phase shift, that means horizontal shift. Now, D is the vertical shift or vertical translation. So it's basically the same. So instead of saying F here, now we're just having sine or cosine. Okay, so it looks like this. It looks like this. Or instead of sine, there's a cosine. Now, one thing that you have to remember of is that the K value right here should be factored out from the X. So if it was 2X minus whatever, the 2 has to be factored out no matter whether that is a common term or not, okay? Now, then going to the graphing portion of it. Now, time to time, I will just ask you to graph the final product of it. And when I ask you to draw the final product of the transformation, all I need is the point. I am not probably going to give you the x and the y axes at all because you don't really need it. So the steps are very simple to do. The first thing is stretch the graph without the coordinates first, or sketch it, not stretch, sorry. But that has to include the reflection. So if you have the A as the negative or the K as the negative, you have to consider that one first, okay? And then find the start point of the graph by using EOA. That's the C value. So that's where your graph starts because your graph moved that much horizontally, right? And then number 3, the new period by 360 times 1 over K. So if there's a K value, make sure you take the reciprocal of it. So basically, this is just a reciprocal. 1 over K means just a reciprocal of whatever the K value, okay? So if it was 2, then it will be 360 times 1 over 2. If it was 3 over 4, then it will be 360 times 4 over 3, okay? Then add that to the starting angle to get the ending point, okay? Because that is your new period. So that indicates how long the graph is from the starting to the ending. That's why we're adding. Now, number 4, then divide the transformed period by 4. So whichever the period, you divide that by 4, which represents each segment from, let's say, the first point to the second point and on. And then use that to find the second, third, and fourth point by just keeping adding, okay? So let's then try this. If I ask you to graph y equals -2 sine 3x plus 90 degrees, and then plus 1. So in this case, if you can see, it's a sine graph. I know sine graph looks like this, but it has a negative in the very front, which is the vertical reflection. So then the graph instead then looking like this, right? Because of the reflection. So graph that first. So that's what I'm going to do. All right, I'm not really going to ask you to be a Picasso of this. So graph that. Now then we basically plot the first point and then draw the equation of the axes. Oh, so I'll just go like that, okay? So there are 5 points that I show, and these are the 5 points that you have to show me. So then we know that the amplitude is 2, right? We know the amplitude is 2, and then we know K is 3, we know C is -90, always a C is the opposite of whatever you see inside of the brackets, and then D is 1. So we know that the first degree should be -90 because that's what the C is, right? C is -90. That means my graph has shifted to the left by by 90 degrees, so it starts from -90, okay? And then our midpoint, or the equation of the axes, is the D value. So in this case, oh sorry, not here, it should be D value. So then here it should be at 1. So all the middle value should have the Y value of 1, okay? And then the next step, as we said, is the period. So we then have 360 times, the k is 3, so it's 1 over 3, and that gives me 120 degrees. So my period is 120, so you basically add that to the starting point because that's how long, or that's where the cycle is going to end. So 120 plus negative 90 gives me 30 degrees. Okay, then it's almost set. We know the amplitude is 2, so that means we go up by 2 and then down by 2 from the middle line. So the y value of the max will be 3. The y value of the minimum will be negative 1. Then rest is to find the x values, which is the new period divided by 4. This is always divided by 4, and that gives me 30 degrees. So you just keep adding 30 degrees from the negative 90. So it's negative 60, negative 30, 0, and then, well, if we add 30 degrees to 0, that basically gives us the 30, so that basically makes sense. And this is our stretched and transformed function. Okay, let's try then a cosine. So I'm going to just draw a line here. Now, then if we have y equals, let's say, negative, well, in this case, I'm not going to do the negative. I'll do 3 cosine 1 over 2 x minus 20 degrees plus, or maybe minus, sure, 4. Okay, so the same thing. First, we have to look at whether there is a reflection. There is none, and it's cosine. So I know it starts from the max and then goes down to the min and comes back up. So draw the equation of the axes, and then we know this equation of the axes, and it's happening at negative 4 because of our d value. So our starting point, which is max, comes back down to the middle, minimum goes back up and goes back up to the max. So then all we need is the coordinates of these. Now, then if you look at it, the midpoints are always the equation of the axes, so we know these are negative 4. Now, then we know the starting degrees is at 20 degrees, right? Because our C value is 20. And then we have to find the period. So 360 times, remember the reciprocal of the K value, so this case is 2 over 1, and that gives me 720. So add 720 to the beginning, or the starting value, which is 20. That gives me 740 as our one full cycle ending point. Okay, so from 20 to 740, it takes 720 degrees, which is our period, so that makes sense. Then all we have to do is to find the rest of the y values by looking at the amplitude. So amplitude is 3, so from negative 4, which is the equation of the axes, we go up by 3, so it is negative 1, and then we go down by 3, so the minimum is negative 7. Now then, just need to find the x values of the middle ones. So all we have to do is 720, the period, divided by 4, okay, to see how much of the increase we should get, and that gives me, I believe, 180 degrees. So you keep adding 180 degrees to the starting angle, which is now then 220 plus 180, that's 200. 200 plus 180, that is 380. And then plus 180 to that, that gives me 560, I believe. And then we add 180 to that, that ends up at 740. So that perfectly makes sense. So that is a good indication that whether you have actually found the degrees correctly or not, okay? So that's how we can sketch a graph of a function using the transformation, okay? There's another way that will ask you to go step by step, but it's basically the same, okay? It's basically the same, just take one at a time. Now, then the last one. So the last one is then trying to find the equation from the graph. So basically it's the backwards. So I'm going to do one example. It basically is the same as before. So the first thing is find the max and min, okay? So find the max and min. And the reason why we're trying to find the max and min is it actually tells us the three things. It tells us the amplitude, it tells us the equation of the axes, but it also tells us how long the period is as well, okay? So finding a max and min is very, very important. So in this case, in this graph, my max is, let's say, from here to here. Now ignore this equation that I put here or that came up with. That's just a part of the graph that I actually found on Google. So our max is starting from 45 degrees and it's ending at 225 degrees, and it's at 9. Now the minimum is happening at somewhere in the middle. I believe this is 135 degrees, and then it's at -1. So I will just write it. This is what I always do. Max is at 9, min is at -1. Now using this, the amplitude, as I said before in the on the 5.1, it's the max minus min divided by 2. So in this case will be 9 minus -1/2, and that gives me 10/2. So my amplitude is 5, okay? And my D value, the EOA, so EOA, I will just put a D in the brackets, is then max plus min divided by 2. And that gives me 9 plus -1/2, that is 8/2, so that is 4. So my equation of the axis is 4, and my amplitude is 5. So to double check, I will just draw a dotted straight line representing the equation of the axis passing through 4. Okay, and I will actually double check whether my calculation is correct. So from 4 down here, if I go up by 5, I get to the max. If I go down by 5, I get to the min, which is -1. So the amplitude is indeed 5, and the equation of the axis is 4. The reason why I'm telling you is this, because time to time you mix it up, okay? So when you find A and D, I want you to actually try to just draw the dotted line and to see whether your amplitude is and the equation of the axis is correct. So then from that, I told you we can also find the period. So in this case, period is always from maximum to maximum or minimum to minimum, okay? In the case where you only have a maximum and the minimum right next to that, is then you basically find the length of the distance between those 2 points in terms of the horizontal way, and then you times by 2. But in this case, we have 45 degrees to 225. So the period is 225 degrees minus 45 degrees, and that gives me 180 degrees as the period, okay? Now, you may ask me, can I simply just choose the middle ones? Yes, you can do that, but time to time that can be somewhat ambiguous because the point is not landing or crossing the corner of the grid, okay? Now, then we have done number 1, then we have done number 2. So we then have to multiply 360 by 1 over the period, and that gives us the K. So 180 divided by, oh sorry, not 180 divided by, 360 times 1 over the period, and that gives me 360 over 180, so that is 2. So this is my K value. So we have found A, K, D. Well, now then we have to find the C. So in this case, I ask you to find the sine function, and we know that the sine function starts from the middle, right? So I can say, this is my middle point to start, and goes up to the max, comes back down to the middle, and then minimum, and comes back up to the middle again. So I can say this is my cycle, okay? Okay, so in this case, my graph is starting at 0, so my C is 0. So therefore, by putting everything, I can say it's 5 sine 2 x minus 0, so I'll just put x and then plus 4. So this can be our graph, or the equation of the graph. Now, is it the same as what's written up there? Yes, it is. Time to time, then you may ask me this. But Mr. O, I want to choose something else. I want to choose, let's say, this segment right here. I want to choose this. Can I choose that? Yes, of course you can choose that. But then your equation changes slightly. So this one I'm going to use in blue, okay? This is a last remark. Now, if you choose this red or pink highlighted portion as your graph, then you can say this is my starting point. So this becomes your C value instead of the 0. Now, then if this is a sine graph, so you're going down instead of going up to the max to begin with, that means there's a vertical reflection. So your A is the negative value. So then it can be y equals negative A, so negative 5 sine. Rest is the same, 2, but your starting point is at 270, so minus 270 plus 4, okay? So your answer can be different from mine depending on where you choose as a starting point, or maybe your textbook answers, depending on where you choose to start the graph with. But it basically is the same. Okay, so when you see different answers, don't panic. Compare that to your friends or ask me and compare it to mine, and you will actually eventually figure that out. Okay, so hopefully this video is helpful to summarize these. Okay, see you in class. Bye.